Hello and welcome to part 3 of our observing course. So the next type of objects we're going to be looking at are what we call deep sky objects. Deep sky objects are essentially any objects that occur outside of our solar system's influence, so outside of the Oort cloud. And that includes stars, that includes nebulae, that includes galaxies, um, star clusters, all manner of objects. But we'll get started here with a very popular object for a lot of amateur astronomers are double stars. Double stars are exactly that. There's more than one star in the system. In this case, they are gravitationally bound to each other, often around a center of gravity between the two objects. Our solar system is actually in the minority in this respect because we are just a single star system. So most of the stars you look up in the sky are a multi-star system, 2, 3, 4, 5 stars even. But, it's common to see two together. So this one that we're looking at here is the head of Cygnus the Swan. Look at the constellation the summertime, also known as the Northern Cross. It's a star called Albireo A and B. B is a bluer star, it burns hotter, and A is a yellower or orange star, it burns a little colder. There are optical doubles, which are stars that may or may not be actually stuck in their gravitational pull, but one may be a foreground star, another may be a background star. Some are actually entangled, and they're in each other's gravitational influence. So another example would be star Castor, the two twins in Gemini. That's actually a 5-star system. Rigel has a star around it. Polaris even is a multi-star system, but its star is a white dwarf. So one has exhausted its fuel and the other one is still there. And the one we're seeing is the one that still exists. I mean, through a telescope, you can see Polaris B, which is the small white dwarf. Just so be aware that there are many of these stars here. Another one is the famous double-double in the constellation Lyra the Harp. And that's a 4-star system, and it's 2 pairs of 2 orbiting each other. So there are many configurations you can find this type of star system. And some of them are orbiting so tightly that your telescope can't resolve them. You need a larger telescope and better seeing conditions in order to do that. So the next object we want to talk about are the diffuse nebulae, mission nebulae. Usually it's an interstellar cloud of gas and dust, hydrogen, and some helium. And there's some other ionized gases as well. But this is the material that our solar system was once formed out of. These are where stars are actively being born right now. The most famous one is the Orion Nebula, seen from in the evening skies, late November all the way through early April. And then in the summertime, there's quite a few others, but perhaps the most famous one is the Pillars of Creation in the Eagle Nebula. And those right here you can see in this Hubble image. This is the Pillars of Creation. The very tips over here, these are where stars are being born, and as they ignite, the solar wind will push out that gas and diffuse it. So any material that doesn't get absorbed by the star itself or a planet during formation will be pushed away, and eventually this will dissipate. So this is planetary nebulae, and that's a misnomer. Planetary nebulae are really just stars that are basically about the mass of the sun, or maybe a little less, and they have used up all their hydrogen helium fuel, and they expand their outer shells, and they can no longer hold on to the outer shells, and they just float off into space. And what's left behind is a white dwarf star. So this is the Helix Nebula here. And at the center here is a white dwarf. And this material is drifting away slowly, and eventually that material may be incorporated with other interstellar gases and material and form a new star system one day. Another one that we happen to find are supernova remnants. And so these are stars that are many times the mass of our own sun, and they explode in a catastrophic way. So these are the ones that become not just a red giant, but maybe a supergiant. And then they get down to fusing iron, and once that happens, they can no longer, the reaction is stable, and the whole thing collapses. And then there's an explosion. And the one on the left is that we see in the picture here. That is in Taurus. That's the Crab Nebula, and that happened in 1054. So the Chinese astrologers actually were able to view that, and it lit up the daytime sky when it happened. It was so bright. I'll get back to that in a minute. Here's one that's, again, in the constellation Cygnus, but off to the side on one of the wings of the swan. This one happened much earlier, many thousands of years earlier, and you can see the material, the gas, and the dust is expanding far and away. This is, when you look at it, this takes up a much larger part of the sky than this one. This one's zoomed in. But that's what happens. The material drifts away into space until it eventually can, either dissipate completely or be reincorporated into a new star system. So back in 2014, the galaxy called M82, it's one of the two galaxies off the pot of the Big Dipper, very well-observed galaxy. Back in January 2014, there was a supernova visible in here. And so it's brighter. It actually outshone the galaxy. You can see it by these two little pointer bars over here. And so we observe supernova in other galaxies more frequently rather than our own galaxy, because there are many more galaxies to choose from. So they're not that frequent, but they, because space has got so much material and so many galaxies, we actually can see them far away. Although a candidate like, for instance, Antares in the constellation Scorpius, or Betelgeuse in the constellation Orion, are candidates for a supernova sometime in the future, maybe in our lifetime, maybe thousands of years from now. We're not quite sure yet. So the next object we want to look at are open clusters. Open clusters are a group, up to about a few thousand stars that were formed in a giant molecular cloud, and they're roughly the same age. And these are clouds that were similar to the Orion Nebula or the Eagle Nebula we just looked at a couple of slides ago. They are loosely bound, and I use that word loosely, by mutual gravitation attraction, and eventually they become disrupted by close encounters with other stars, other star clusters, and as they just generally orbit around our galactic center, they get pulled apart. Our sun, after we absorbed all our gas and dust and pushed out the rest, our sun was in a group of stars similar to this, and over time they dissipated, and so we don't even know where the same family of stars are anymore that our sun was born in. This is a different type of star cluster. This is a globular cluster. The reason why we call them that, they're spherical. They tend to be much tighter and dense, and they are old stars, and much older. They tend to be in the billions of years old. So these are most are generally 10, 11 billion years of age. They're very tightly bound by gravity, and it gives them that shape. And they have a high density of stars towards their center. The next object, we want to look much further out, and this is outside of our own galaxy, other galaxies. Basically, it's a gravitationally bound system of stars, stellar remnants, interstellar gas, and dark matter. Again, these stars can number in the billions, and these are like our Milky Way. They vary in size, shape, um, density, and age. So for as many billions of stars that we have in our own Milky Way, there are many other galaxies out there, mostly drifting apart. Some are coming towards each other with the universe expansion. But for the most part, we measure the light coming from these in the millions of years distant. Not including our small and large Meningella clouds. The closest one would be the Andromeda Galaxy, and that's about 2.5 million light years distant. So when you're looking at that through your eyepiece or through a screen on a camera projection, that light, left many millions of years ago. So we're going to go briefly to some of the brightest and most popular deep sky objects and see where to find them in the sky, generally speaking. So in the springtime, DSO is short for deep sky object. We're looking at, the constellation Cancer, the crab over here. And we're kind of right in the middle here. And that's M44. That is again, young stars. It's an open cluster. And then again, these used up their gas and dust, and they're drifting their separate ways. But this is actually a better binocular object than it is a telescopic object, unless you have a really, wide field telescope. But it's just amazing to look at these, and these are viewable in the spring. Usually, I would say early March, late February is the best time to view this object. And spring, early summer, so we want to look at certain galaxies. And the Big Dipper, if you remember back in the lesson with the constellations and their movements to the sky, during this time, it's kind of standing on its handle in the northeast, and you're kind of going out in a 45-degree angle off of the pot of the Big Dipper, and you can find Messier 81 and 82. And these M numbers are short for Messier. That's Charles Messier made a catalog of deep sky objects, and these are number 81 and 82 on his list. And a lot of stellar catalogs will have a number notation after them. And again, the light from these two galaxies are about 11 million years old. So it takes 11 million years for the light to get there. So when you get into late spring, early summer, Hercules is a good place to look for globular clusters like Messier 13 is kind of in the armpit area. Here's the keystone, his chest. M92 is up over here. And these are two, again, bright objects. And you can view them in a suburban environment. Again, the larger the telescope you use, the more detail you will resolve. Lyra right near Hercules, actually. So it's more of a summertime object. Lyra the Harp. Incidentally, when we were talking about the double before, double stars, Epsilon Lyrae is over here. So you'd have this part Vega, this part of Lyra here is at a part of the Harp, and that has the double. But down here at the bottom of the Harp is the Ring Nebula. It's a very famous bright planetary nebula. You can see the white dwarf star. An 8-inch telescope will easily resolve this particular object. You want to put a little bit of power on it, maybe 200 power or so, to really, if you can, to resolve more detail. This is very distant too. It's for a object within our Milky Way, it's 2,300 light years away. Then next is another similar planetary nebula, but it's a little bit more expanded, called the Dumbbell Nebula. It's also known as the Apple Core Nebula. So you can see Cygnus the Swan if it's directly overhead. There's Albireo, that's the head of the swan. The bright star Vega is over here, and there's M57, the Ring Nebula. So if you take a line down from Vega, draw it through Albireo, and it'll kind of get you right past Visceptula. It'll kind of get you right in the area where the Dumbbell Nebula resides. That's 1,360 light years away, and this is visible from, summertime all the way into the mid-autumn, I would say. Depending on if you have a good western horizon, you can see this pretty well. Even in a suburban area with a light pollution filter, an 11-inch scope will resolve that. If you go out to a little darker sky, an 8-inch scope, an 8-inch telescope will easily resolve this. So going to bright autumn objects, one of the best, actually the only globular cluster of autumn, is Messier 15. So if you look at the keystone over, not the keystone, sorry, the great square of Pegasus, so that's the torso of the horse, and you kind of go over here to the head, the bright star Enif. It's kind of a yellow star, and you go off on an angle, and you will find Messier 15. It kind of points to it. So another way to find the Andromeda Galaxy, either with a pair of binoculars or a telescope, I tend to use the W shape in the constellation Cassiopeia, and the star Scator in particular. I like to use that to point to the Andromeda Galaxy. So you've got 3/4 of the way out to Andromeda from Cassiopeia is where the Andromeda Galaxy lies. And if you're in a relatively dark sky with no moon, you can even see it naked eye. If you go to our club observatory at Jenny Jump State Park, I've seen it naked eye. And this is, again, about 2.5 million light years distant. And eventually this particular galaxy will collide with the Milky Way. Another really good open cluster is the Great Perseus Double Cluster. So oftentimes I'll use the two central stars off of the W in Cassiopeia and just go straight down with my telescope. If I'm not using a go-to telescope, I can find the Perseus Double Cluster. And it's almost, again, perfectly in line with Scator as well, coming straight down from that. And these are two large open clusters drifting, and the stars are young, drifting away from each other. Again, best to view this with either a wide field eyepiece or a rich field telescope. Even binoculars would resolve these. So we also have the Hyades open cluster in Taurus. It's the V area where Taurus starts to separate. This particular part of Hyades here is again another open cluster of stars, and these are really separating out. Aldebaran here is actually a foreground star. It's not part of that cluster, but it just happens to be in front of that. Also, towards the front of Taurus is the Crab Nebula. This is Messier 1. Again, you want to use a darker sky sight and a telescope with as much aperture as you can to view the Crab Nebula. The Pleiades is another open cluster. Often you see it up to the upper right-hand part of Taurus. Almost looks like a shopping cart. And it's quite visible to the naked eye. And it's often known as the Seven Sisters. There are many more stars in it than that. Again, these are young stars, about 200 million years old. or so. And these are drifting apart as well. These most likely at some point will live fast and die hard because they're blue-white in color, which means they will burn through their fuel pretty quickly. And you may wind up having a supernova in the future from some of these stars. Other stars that are great in wintertime, Auriga the Charioteer, if you look at your star chart, usually find them in January is a great time. So M37, M36, M38, and even M35, a little bit to the lower off the screen here. Particularly M37 is one of the very best open clusters. Almost resembles a globular cluster, but these are nice targets as well. The Orion Nebula is, again, the most famous deep sky object of winter, perhaps one of the brightest, definitely the brightest nebula. It's 1,300 light years away. So if you look at Orion's belt over here, and you go straight on down, that's the sword. Right in the middle of the sword is M42, the Orion Nebula. And so I included 3 different views here, which are within perspective. The first one, obviously, is ESA image. So this is a astrophoto. Don't expect for it to look that way. But, through an 8-inch telescope in, let's say, the Montclair area, suburb area, you will see just a little bit of nebulosity and the trapezium. If you were to come out, let's say, to Jenny Jump State Park, or most of the way there, Bortle 5, Bortle 4 sky, you will be treated to the wings, the trapezium, and in quite a bit of detail. If you were to go out to a really dark sky, let's say Cherry Springs State Park or the Adirondack Astronomy Retreat up in the Adirondacks, this is the kind of detail you would get, because the darker the sky background, the more nebulosity comes through. And so this is a typical star chart. I have little arrows pointing. This is a winter star chart. It's be a January star chart, and it shows you where all of these deep sky objects are. At Cancer rising in the east, you can see M44 Beehive cluster, right? All the way in the west is M15, so that autumn deep sky object is setting. M42, the Orion Nebula, is pretty high up in the southeast at this point, perfect for observation. M36, 37, 38 in Auriga, M1 in Taurus, right? The Perseus double cluster, and the Andromeda galaxy. So these are the brightest objects. There are other objects, obvious, that you can see as well. If you wait late enough in the evening, you can even see M81 and M82. But the deep sky objects, again, these are background objects. They follow the same type of patterns as the constellations, and they're around only in certain seasons. So use your constellations as a guide as to where to find these deep sky objects. All right, thank you very much.